Good morning. We are gonna talk about water treatment. My name is Earl H. Fabian and my groupmate is Russell Factor. First, I'm gonna talk about some history from the water treatment. In ancient Greek and Sanskrit, writings dating back to 2000 BC, water treatment methods were recommended. People back then knew that heating water might purify it, and they were also educated in sand and gravel filtration, boiling, and straining. The major motive for water purification was better tasting drinking water because people could not yet distinguish between foul and clean water. Turbidity was the main driving force between the earliest water treatments. Not much was known about microorganisms or chemical contaminants. After 1500 BC, the Egyptians first discovered the principle of coagulation. They applied the chemical alum for suspended particle settlement. After 500 BC, Hippocrates discovered the healing powers of water. He invented the practice of sieving water and obtained the first bag filter, which was called the Hippocratic sleeve in around 300 to 200 BC. Rome built its first aqueducts. Archimedes invented his water screw in the 1700s. The water filters for domestic application were applied. These were made of wool, sponge, and charcoal. In 1804, the first actual municipal water treatment plant designed by Robert Thom was built in Scotland. The water treatment was based on slow sand filtration, and horse and cart distributed the water. Some 3 years later, the first water pipes were installed. In 1854, it was first discovered that a cholera epidemic spread through water. The outbreak seemed less severe in areas where sand filters were installed. British scientist John Snow found that the direct cause of the outbreak was water pump contamination by sewage water. He applied chlorine to purify the water, and this paved the first way for water disinfection. Since the water in the pump had tasted and smelled normal, the conclusion was finally drawn that good taste and smell alone do not guarantee safe drinking water. This discovery led to government starting to install municipal water filters, sand filters, and chlorination, and hence the first government regulation of public water. Water treatment is performed in order to improve water quality. The processes employed for water treatment depend on the quality of the water supply. In all cases, water has to be disinfected in order to deactivate any existing microorganisms present in water. So far, this technique was proved to be the most important for the protection of human life. It is commonly done using chlorine or chlorine dioxide, and in many cases, other processes such also called also used such as ozonation and ultraviolet irradiation, which destroys the microorganisms using ultraviolet lights. If the water originates from a surface water supply such as a river, lake, or dam, then the suspended particles are the most important problem. Different techniques to remove suspended particles include the addition of coagulants and the use of membranes. If the water originates from groundwater through mountain springs, usually the water quality is good, and in most cases, only disinfection is required. However, if the water originates from groundwater wells, it may be rich in metals that need to be removed through chemical precipitation. Softening is another technique commonly used to remove hardness in case water is hard, which is performed by the addition of lime and subsequent precipitation of calcium as calcium carbonate and magnesium as magnesium hydroxide. The water treatment process. This is an example of a conventional surface water treatment. As you can see, it came from a water source, which is a usually a river or a lake. First, the collection. The source water for municipal surface water treatment plant is typically a local river, lake, or reservoir. There must be a method to get this water to the water treatment plant. Quite often, a series of pumps and pipelines transport the water to the treatment plant. Many water treatment plants utilize water from more than one source. Blending groundwater with surface water is a method often used to improve the quality of the final product. First, we need to screening and the straining. If you think about the surface water sources, like lakes and rivers, you realize that they contain varying amounts of suspended and dissolved materials. This material may include turbidity, color, taste, odor, microorganisms, fish, plants, trees, trash, etc. The material may be organic or inorganic, suspended or dissolved, inert or biologically active, and vary in size from colloidal to a tree trunk. Some of these larger items can impede equipment in the treatment process, such as a tree limb, getting stuck in a water pump impeller. So the first process in a conventional water treatment is to screen out or strain the larger items. This is often accomplished by using large metal using bar screens. Once the pre-screened source water is received into the treatment plant, chemicals are added to help make the suspended particles that are floating in the water clump together to form a heavier and larger gelatinous particle, often called floc. In this process, a chemical is added that reacts with naturally alkalinity in solution to form an insoluble precipitate. There are many different chemicals on the market that are used in this process. These chemicals are called coagulants. Coagulation, fluctuation, and sedimentation. A rapid mix is usually used where the coagulant is added to the water to provide a very quick and thorough mixing. The water mixing is then slowed to allow the water to come in contact with the forming floc and allow to increase it in size. The continued mixing must be gentle to allow the floc to grow and gain weight, but fast enough to keep it in suspension until you're ready for it to settle in the clarifiers. The treatment unit where the coagulation and fluctuation is performed is called the fluctuator. Once the fluctuation process is complete, the water then passes over the weir in the fluctuator and travels to the center of the clarifier or sedimentation basin. Here, the water makes its way from the center of the clarifier to the sawtooth weir at the perimeter of the unit. As the water makes its way towards the weir, the large flock particles are allowed to settle at the bottom of the clarifier. A rake continuously travels across the bottom of the clarifier and scrapes and the settled flock to the center of the unit. Pumps are used to settle the settled sludge out of the clarifier and send it to the sedimentation or disposal pond. The water that passes over the weir is collected and transferred to the filters. The reason clarification occurs before filtration is so the majority of suspended material can be removed prior to filtration, which avoids overloading the filters and thus allowing much more water to be filtered before the filters must be backwashed. Next, filtration. Clarified water enters the filter from the top. Gravity pulls the water down through the filters where it is collected in a drain system at the bottom of the unit. There are many types of materials used in filters, the most common being sand and gravel. Many conventional plants are now using granular activated carbon as the media of choice because it not only provides excellent mechanical filtration of particulate matter but also removes organic compounds which can cause taste and odor problems. Next is disinfection. Once the water has gone through the filtration process, it is about as clear and clean as it can get. However, there may still be bacteria and viruses remaining. To ensure these are destroyed, there must be a disinfection process employed. The most common disinfection process used in the United States is chlorination. Chlorine comes in many different forms, including chlorine gas, most common, chlorine dioxide, hypochlorite, which is bleach, and others. Whichever method is used, chlorine is added to the water in an amount to ensure all microorganisms are destroyed. Water plants monitor the chlorine levels continuously and very carefully in the treated water. They must add enough chlorine to ensure thorough disinfection of the water but avoid excesses that can cause taste and odor problems when delivered to the consumer. Once the disinfection process is complete, the water is stored. Storage usually takes place in an underground storage tank called a clear well and also in elevated storage tanks that are visible around town. There must always be an ample supply of water available in the event of emergencies. This can include power outages, fires, floods, etc. The stored water is pushed through underground pipelines all over town in what is called a distribution system. The distribution system consists of large water pumps at the treatment plant, overhead water storage tanks, large pipelines and smaller pipelines, fire hydrants, valves, and water meters in our front yard. The stored water is pushed through underground pipelines all over town in what is called a distribution system. The distribution system consists of large water pumps at the treatment plant, overhead water storage tanks, large pipelines and smaller pipelines, fire hydrants, valves, and water meters in our front yard. One of the many applications of water treatment is the treatment of water for drinking. Without water treatment, our drinking water would not be clean and may cause a lot of diseases and outbreaks of waterborne diseases. Places wherein water treatment plants are rare, portable drinking water filters have a huge impact in these communities and provide a step for providing them clean drinking water. Also, we use treated water for plumbing. We use it for our showers, for our laundries, the water that comes out of our sinks. And water treatment enables us to access clean water every day, 24/7.
A specific end use also applies to irrigation. The treated water helps to grow agricultural crops, maintain landscapes, and revegetate disturbed soils in dry areas. Water treatment helps us achieve environmental sustainability in the following ways. Number 1, reduction of waste. Water treatment reduces the volume of waste that is released into the ecosystem. When wastewater is treated, the quantity of waste that is released into the environment is cut down significantly, resulting into overall improvement in the environment status. By cutting down environmental pollution, water treatment helps to reduce health hazards that emanate from a polluted environment. Number 2, source of clean water. Water treatment will ensure there will be a balance between water supply and demand. Through filtration of harmful contaminants from wastewater and giving out hygienic and safe water, there will be adequate supply for everyone. Number 3, production of fertilizer. Sewage sludge is a byproduct of treated wastewater. It is composed of both organic and inorganic materials. A large concentration of plant nutrients, organic chemicals, as well as pathogens. The biomass that is produced from the sludge phase is decanted and dried. Once the sludge has been effectively dewatered, it can be buried underground in a sanitary landfill or can be used as a fertilizer. Number 4, disease prevention. Wastewater contains potentially harmful bacteria that can make consumers of water contract parasitic infections. Water treatment therefore plays an essential function in removing pollutants from water that could be awfully harmful if consumed. And number 5, clean environment for recreation. Wastewater treatment ensures people will be able to enjoy water sports without having to worry about water pollution. Water from treatment plants can also be supplied to areas experiencing drought. Thus, water treatment is an eco-friendly process that helps in reducing water wastage by recycling water that would otherwise have been deemed to be unsanitary and end up being disposed. Advancement in water treatment. Nowadays, water pollution and freshwater scarcity have become a serious problem worldwide, causing concerns to both public health and the environment. To reduce these challenges, various treatment technologies have been adapted. Among these technologies, nanotechnology and biotechnology-based techniques are usually applied separately for water and wastewater treatment. With the development of nanotechnology, its application in water and wastewater treatment is becoming increasingly popular. Freshwater contamination by heavy metals, organic and inorganic compounds, and other microorganisms are a topic of important concern in both developing and developed countries. The disinfection and microbial control, catalytic oxidation, and other applications of nanomaterials offers several advantages because of their unique physicochemical characteristics such as large specific area, higher reactivity, and small size. Environmental biotechnology deals with the application of biological processes to protect and restore the environment from pollution-causing constituents through the suitable use of biotechnology, alone or in combination with other technologies. Research and innovation in environmental biotechnology are crucial in developing scientific solutions for preventing, mitigating, and reversing environmental destruction with the support of microorganisms. The process of water treatment has many benefits, and that makes it viable in the long and short term answer to the water crisis bedeviling the world today, which keeps on multiplying simultaneously with increase in world population. Mathematical models project the world population to increase up to 9 billion people in the next few years. This is bound to increase the volume of wastewater that will be produced, making water treatment a critical aspect of environmental conservation and sustainability. Expanding wastewater treatment sector will produce large quantities of fresh water and help bring down the level of water scarcity. What water treatment processes are considered essential to reliably treat physically and bacteriologically contaminated surface waters for domestic use? Thank you for listening.